because obviously a lot of these, like the vast majority of all species that have lived have gone extinct, and you can
Right.
predict like extinction drift. You can predict extinction risk as a function of the species age, just using like simple like ecological drift models.
Yeah,
So
it's pretty cool.
like ecological drift like pretty much explains like the age of certain of most species just as a general trend.
But so if you're taking the origin of birds, let's say Archaeopteryx, you guys would say that's a transitional form. We
Yeah.
got traits from theropod dinosaurs and also extant or modern birds. So you would, let's say 65 million to 100 million years ago, the origin of birds from theropod dinosaurs. Well, even with extinction rates, extinction events, today we're only left with 10,000 to 17,000 species of birds. From the flood 4,500 years ago, that makes sense because we understand today that speciation and adaptation can be rapid. If we start with design diversity and those DNA differences are built in from the start, then speciation is really rapid because the ones documenting these new bird species, they obviously are evolutionary scientists, so they don't believe in design diversity, but even they're admitting that speciation is happening rather quickly. We're observing it in real time. So take that back 4,500 years ago. Boom, it's easy to account for.
Speciation,
I just want to finish my thought. So it's easy to account for that many species. Okay, but for the evolutionist model, why is there only 10 to 17,000 birds? But you take it back 65 million to 100 million years ago, there should be hundreds of thousands of bird species. And I get there are extinction events, but how many extinction events do you have to invoke to explain why there are so few bird species today? And do you have numbers for that?
Ecological
Most
drift
species
can
are
account for
extinct.
a lot of this.
Well, first of all, species is just an arbitrary category we made up. We'll categorize things into like this is this species because it's one sole category. So we can invent new species by simply stricken up the category. What fits that X in X category.
Well,
they're literally just made up.
I will also note that's very much a continuum as well. So like when you're talking about that 2023 study with that new species of finch, for example, if you looked at the ancestral finch species and the new one, you wouldn't be able to tell them apart. They're at the very cusp, basically, of the speciation process, because it's not a matter of, okay, you're one species and then another moment you're a different species. It's a continuum of change, and that continuum takes a very long time typically.
Well, this is just arbitrary saying, am I identical, like an exact copy of my mother? Of course not. Of course, it's going to be the mixture of those.
Just to answer Donnie's question, like ecological drift goes a long way to explaining how you have like both periods of like lower diversity of species and increasing differences among like otherwise equivalent communities. So like ecological drift is a mechanism by which this happens, and like I said, that it trends very well into predicting like species age and extinction rates.
So when you say ecological drift, and if I missed your definition of it, I apologize. Are you arguing that some species, they can fill a niche to the point where it no longer needs to be filled, and so it remains static and remains that way for a long time, and so there's no need for growth? But then other periods of time, there is significant growth. Is that what you mean by ecological drift?
It's kind of like genetic drift in that it's like essentially a stochastic process. It's just like the changes in like a population size due to like births and deaths over time. Like it's like essentially stochastic process.
So if there's an extinction event, will it fluctuate upwards for an extended period of time as it rebuilds its numbers and then becomes a little more static, stays at a constant number for more or less for a while?
Here, I sent a link in the private chat of just like a study about it, but I also just recently like saw like basically like an ecological drift model that was able to like it's similar to neutral theory, but it's essentially able to model and predict like extinction risk over time for species.
Because I'd like to see, because I would like to see a sophisticated analysis with numbers on whatever species. Name your species. Let's take bird species. I think Nathaniel Jensen has done a very good job accounting for at least the bird species and putting numbers and predictions and so on and so forth. But we could do the same thing with snakes, lizards. You know, there's not a whole lot of lizard species, 4,600. And I think with what Andrew said, because he makes an interesting point that yes, the difference between the new species and the parent species is pretty minor. And so the larger question is, should we even be calling it a different species? Because the number of species per animal that we look at could be inflated. Because depending on if you're a splitter or a lumper, we could prematurely be labeling something a new species just by a very small difference. Or somebody might think, no, that's not really enough to...
It's arbitrary because we can like say, let's see, we get a population of people with Down syndrome in the school. They would be considered a new species technically because the category is Down syndrome. Let's say people with, I don't know, webbed toes because a mutation that's made them, you know, slightly inferior. Well, now the category is webbed toes and we just invented a new species. It's arbitrary. Because you can add up all these, you can keep adding categories and categories and keep inventing species.
Well, this is something I think that was being talked about in the debate with Kent, is this so-called species problem and how there are many different species concepts, because it is true that organisms can't be filed into these neat, tidy categories or boxes that we would like to call species. It's very much more variable than that, and that's why you need to use different information in different areas. With like fossils, for example, you obviously don't have any DNA data left, so you have to use a morphological species concept. So it's valuable for different questions you're asking. But since organisms can't be filed into these neat categories, that's more of a result of evolution, not like created kinds kind of thing.
Well, look, since this line of thinking going down species, this wouldn't be evidence for evolution or against it because it's so arbitrary.
Well, yeah, it's not like a specific, it's not like a numerical prediction, but it's consistent with the idea of evolution, because you want to, if lineages are continuously splitting off from each other and diversifying in very different ways, you wouldn't expect
but that's also expected in the creation,
like kind, for example.
Like, for example, web feet is also expected in the creationist model. So like this is data that doesn't like distinct which one is true. So you need some actual data that actually creates a distinction. So like we both expect there to be web feet.
Well, in that case, I would just ask what would distinguish them then. What unique prediction does creationism make that hasn't been tested yet?
For example,
hey, Donnie, I have a question. Would you be okay saying that instead of one ancestral pair of dogs that produce all the dogs that we have now, whatever 300 species there may be, would you be okay with saying that maybe there was a handful of dogs on Noah's Ark rather than just one dog? Like there was like some big dogs, medium dogs, small dogs, 3 pairs of like kind of diverse dogs that would have been interbred once the Ark landed, as opposed to just saying that there was one set of dogs that produce Chihuahuas as well as Great Danes. Would you be okay with saying that, or would you still argue that it should all comes from one pair of dogs?
Josh, you already answered that.
Are dogs biblically considered clean or unclean animals?
I don't think that was his question.
I have a thought about those dogs. Well,
because I just want to answer real quick, because depending on if it's clean versus unclean, the Bible says take 7 pairs of some or 2 of others, right? Because so I think it would come down to, because I don't think there's an issue having 2 wolf-like ancestors as the archetype with an incredible amount of allelic variability and potential for change to explain all the different species we see today, which are not a whole lot. And then also with artificial selection, getting all the domestic dogs, about 400 plus domestic dogs that
Not
that
to
we
say
see
that
today.
dogs are unclean, Donnie, but even them being unclean, like what we would consider how we have grouped dogs nowadays, you know, they may have been seen as different types of animals. Like this one is really big dog, this one is really small dog. So
Right, there could have been like the dog kind, there could have been the wolf kind, the fox kind. There could,
yeah,
you know, with felids, I believe that tigers and lions are related. They go back to an archetype that was a felid, but there are some Cretaceous I know that believe there was a tiger kind and a lion kind. So, you know, there's definitely questions there for us to engage,
I have a
ponder, and
question,
study.
Donnie.
The big
For the
issue, I just
dog,
want to say, the big issue is that Noah's Ark can only be so big. So you can only fit
Right.
so many different kinds on it. Like you can't just have every species is its own kind and still everything fit on Noah's Ark.
That's why I would rather have just a pair of canids as an archetype, and from there you get all the different species, and then you get a group of humans. I think the evolutionists would agree. Groups of humans, however many years ago, in evolutionary time, not that long ago, took some wolves, domesticated them. They're even domesticating, from my understanding, foxes today.
yeah.
And very
Russia.
interestingly, the foxes are becoming a lot more like some
yeah,
of the
that's
dog
pretty cool.
pets that we have.
No, they're just
Yeah,
becoming
Donnie, you
There's
already,
actually been some
qualify
evidence that,
anything.
that they may have domesticated the mammoth too.
oh, Donnie, you already, I mean, already asked you just to clarify. Like, so what happened was Noah, like, just like you said, Noah, he got some canines that had the perfect amount of genetic, what's the word I'm looking for?
Variability.
Yeah, genetic variability to result in the kinds we see today.
Yeah.
That's precisely how it was. I don't know what
In-
Josh must have not heard you because he kept.
Well, and
he asked
remember,
the question.
there's a lot of studies though right now that says environment can dictate phenotype. And so if we're saying there's a lot of morphological adaptability built into each kind, well, what happens for the first 1,000 years after the flood, according to the biblical model, is some very harsh environmental changes and conditions. And so a lot of these creatures that come off of the ark, the potential is there in the genome, but also in the environment for a lot of this front-loaded morphological adaptability to be manifested outwardly in change. And then maybe the speciation rate has slowed down after that first 1,000 years after the flood. But I would imagine that speciation rates were probably even quicker for that first 1,000 years after the flood, as these creatures have to migrate to less than ideal parts of the world and rapidly adapt or vary. Go ahead, whoever wants to talk.
If I
Wait,
can
I wanted to
add,
ask-
Yeah.
Bubblegum wanted to talk. Bubblegum, you go.
I was gonna address one of the points Andrew made earlier because he said like, well, we wouldn't expect a crocoduck, but then, well, we do have an example of that. For example, the platypus. And
No.
so, are you gonna take that as evidence?
What is mosaic with the platypus?
It's a mammal that lays eggs.
That's the ancestral characteristic of mammals.
Yeah, that's
no,
not.
Andrew's argument was saying, well, evolution
it
wouldn't
lays
expect
eggs
a
as
crocoduck.
venom, gives milk, lactates without nipples. There's so much.
Well,
There's so
venom
much
has
to
evolved
about
several
this.
different times. It's not like uniquely snake venom, for example. It's its own type of venom.
Yeah.
in the
But
platypus.
It's
Like
its
none
own
of
type
those-
of venom.
you-
And
those are
also,
being-
it has
wait.
a sixth
Bubble,
sense.
you were trying to say that was an example of mosaic with things that evolution would not predict it to be mosaic for. But
No,
that's just not the case.
that was I was talking about the bear. That was a different argument. That was towards you. I was talking
You
about
said
the
the
bear and
platypus.
gorilla. No, this is towards a different comment that Andrew made.
Well, he said you wouldn't expect to find a crocoduck, and you're trying to use a platypus as an example, but there's reasons why it's not an example of that. Like the
Right.
bill that a
It's
platypus has
exactly an
is
example of
not
that.
anything like a bird or duck bill. They are
Well, what about
morphologically different.
the
crocoduck
elephant
argument
too?
is supposed to be like elements of mixed animals. A crocodile,
Yeah,
you got
exactly.
the,
And a platypus doesn't have that.
yes, it does. It's a mammal that has venom and lays eggs.
Grayson, what are your thoughts? Because I know you're a platypusologist. I knew when Bubbles brought it up, you're gonna go off on that. So I am curious as to your thoughts on. Correct me if I'm wrong. The platypus has claws like a reptile, and it also has hair like a bear. So how do those
Okay, because it's a mammal. Nothing about like there are tons of mammals that have claws and tons of mammals that have hair, and yeah, like in terms of the traits of like how mammals evolved, like mammals like evolved from a common ancestor that laid eggs. It wasn't delivering live birth. That's why you have monotremes as the most basal group, which platypus are a part of.
So maybe I can.
What's the precursor to the extant platypus?
Yeah, I'll let Andrew clarify real quick.
Go ahead.
So I just want to clarify my original comment. So in the context of the crocoduck, looking at blending features of very distantly related groups, the blending you're concerned with here is blending of features unique to one group and unique to this other separate group, and putting them in the same animal, right? So you can have features that can change pretty easily, like the hair texture or fur or color, etc. If you have an animal that blends some of those, that's not really that important in an evolutionary context. Whereas if you saw like a mammal with distinct bird feathers, for example, that would be an example of a crocoduck kind of thing. The platypus doesn't really qualify for that. I hope that makes sense.
How many mammals lay eggs, Andrew?
The echidna does as well.
Yeah, monotremes. There's like 3 groups of mammals. There's like placental mammals, there's marsupials, and there's monotremes. Monotremes lay eggs.
So if there's only 2 kinds of egg-laying mammals on the planet today,
there's 4.
What's the other 2? We got the monotremes.
There are many.
Yeah, the monotremes have like 4 species today.
Okay,
somewhere around there. 4 types.
But are taxonomists not just forcing these interesting mosaics into these groups where they might not belong?
No, because they also have uniquely mammal features. These
are not just like forced, like arbitrary categorizations. Like monotremes are all genetically more similar to each other than they are to any other types of mammals.
Yeah, right. But just like in the design world, all SUVs are a lot more like each other than if you were to bring in, or crossovers, than if you were to bring in something else, an SUV or a van. So yeah, I get that there's a group, monotremes, that are all very similar to each other, but how can you not argue that they're an interesting mosaic?
Well, because they're more closely related to mammals than they are to any other reptiles, for example.
So, okay, any group, any creature on this earth that you pick any creature, it's going to have to, by definition, be more similar to another group and more distant to another. Humans are going to have to be more similar to something, and then more dissimilar. So of course, this interesting group, monotremes, are going to have to be closer to one creature than another. My point is that. Oh, good. Go ahead.
Yeah, I know. I just wanted clarification on what point you were making with this, because, like, yeah,
my point is
the categories are not arbitrary.
Well, it's just expected on both sides that every single group on this earth, whether it's creation or the evolution model, that we're going to be able to pick another group that they're most similar to. So monotremes are most similar to mammals.
Okay. So Donnie, are you saying in any scenario you would expect a nested hierarchy? Like there's no biological scenario where a nested hierarchy couldn't have developed. Is that what you're arguing?
Well, pick your creature. It's good. We can find out what it's going to be most similar to. And then
wait,
Lonnie, just because you can, for any species, you can find another species that's the most similar to it, that doesn't mean that you would have a nested hierarchical pattern. I mean, when Linnaeus first
argue it does.
When Linnaeus first noticed this nested hierarchical pattern, he was shocked and couldn't explain it. And he challenged all his peers who, like, this is before evolution. He challenged everyone. How can we explain this nested hierarchy? It was a mystery until evolution.
What? No.
That's like historically.
Well, if I was one of his peers, I could have explained it to him.
Okay, are you saying
the pattern of nested hierarchy is different than just saying these things should be more similar to these things, because you could have like humans.
It's a logical necessity. It's a logical necessity. You can't define a dog by giving it the DNA of an alligator. So all dogs
you're just
have to
non sequiturs at this point, Bubblegum. But
no, it's a logical. That's not a non sequitur. It's a logical necessity. You can't define a dog by using alligator DNA. That's
nobody's
illogical.
Saying that. That's why it's a non sequitur.
Well, that's what you're requesting of Donnie.
If scientists would have came to the original created kind 6,000 years ago, These created kinds were front loaded with pre-existing DNA differences. And those scientists were to do a genomic sequencing and then comparisons. They're going to conclude relationships that aren't actually there. I mean, these creatures were just created, but with pre-existing DNA differences that would reflect a hierarchical pattern, even though one creature didn't descend from another, because pre-existing DNA differences and then similarities in morphology, anatomy, and physiology necessitates a nested hierarchical pattern.
Wait,
just like
so God
the
designed.
it's just like car companies accidentally. It's not like car companies say, okay, we're going to make vans and SUVs more similar to each other than vans and airplanes, or vans and a tractor, a semi-tractor trailer. No, it's just by accident. Just the fact that they're designing things with similar features and similar parts, that necessitates some kind of hierarchy. But the fact that God
I would argue
created
that like different manufacturers can create different SUVs or within a single category, sedans, whatnot, that are more similar to a completely different category just by like what kind of engine they have, what kind of fuel system they have, then they wouldn't be considered in the same categories that are sedans, for example.
Yeah, the whole nested thing is arbitrary. You like saying like all these nested hierarchical patterns. Yeah, that's arbitrary because you can just choose which category you want to go down. And so if you choose a different yes, it is.
This is reflected in genetics.
No, it's not. Absolutely, it's not. It is not reflected in genetics.
Okay, here's a fact is where we find the most dissimilarities.
Here's a fact, right? All mammals are more closely genetically similar to the other mammals than they are to any non-mammals. Therefore, mammal is not
because it's a logical necessity. That's
what makes a mammal a mammal?
Necessity.
Anybody on the panel?
Calling a banana is that arbitrary?
I can answer that.
Andrew, go ahead. What makes a mammal a mammal?
Yeah, so several things, and this actually gets into the other point I want to make, that a group by itself is not defined by a single trait, right? So
it's a group
mammals
of
traits. It's a collection of traits. So mammals are defined by a few things, like just thinking off the top of my head, lactation. They have mammary glands. They have alpha keratin. They have keratinized hair. They have heterodont teeth, so different teeth configurations. You don't see that in reptiles, for example.
What about the middle ear? Is there something unique about the middle ear?
The free inner ear, middle ear bones, basically. So that kind of thing. So it's defined by a suite of characteristics.
The jaw is made up of how many bones?
Less than a reptile. I don't know the exact number, but I think the point that needs to be made is, like, for example, with mammals or just nested hierarchies in general, you wouldn't necessarily expect a nested hierarchy to come out of any biological scenario because of this fact that groups can be defined by many different traits. So, for example,
but here's the thing. But let me just, because you did a great job answering, Andrew, and you were right. Warm-blooded. They're vertebrates, so obviously they have backbones, but I guess that wouldn't necessarily be unique to them. But they got fur, hair, they produce milk to feed their young. You can get into the jaw, you can get into the
lots of
the skull, the middle ear, and all that kind of stuff. Okay, so all of those considering is then by definition, because there's so many characteristics and traits that we're looking at to categorize a creature as a mammal. So we have this group. So of course, this group mammals are all by definition going to be more similar to each other than reptiles, or once you start bringing in amphibians, because they're going to lack that group of traits or characteristics that make a mammal a mammal. So why would we ever believe that there wouldn't be a hierarchy in terms of mammals, reptiles, amphibians, and then the ones in between?
Yeah, that's a good question, because you could see a more random combination. So, for example, you could see what would usually classify as a mammal with like all the defining mammal characteristics, except it lacks that inner jawbone, or it has a uniquely reptilian feature. For example, it has scales, but it has all the other defining characteristics that we would tend to associate with mammals. So if we had that kind of random combination, then the nested hierarchy would break down. If there was no evolution or modification over time, with this change happens first, and then it's inherited, and then this other change happens for next, and then that's inherited, and so on and so forth, then you wouldn't get a nested hierarchy. You would just have a random mixture of features that would just be due to chance.
Andrew, I appreciate that. I do have some responses, but I want to be fair. Redefine apologetics, my brother. Great to have you. You've been very patient, and I know you wanted to respond and make some points. So feel free to have the floor and respond to anything you'd like to. Just make sure to unmute. I see you're muted right now, and you're good to go. Are you able to hear us? Redefine apologetic.
Okay. All right. I think I have a lag on my part, about 12 seconds, give or take. There's a question I wanted to ask. I guess I can hear you. I can hear you. Okay. So the question I have, if evolution, I don't believe in evolution. I say nothing evolves, but people call speciation evolution just so they can say, yes, we see this happening, and that is evolution. Speciation is not evolution. It's just something that people call evolution so that they can say, see, here's evolution. But my question is for those, I heard someone say that evolution predicted this and predicted that. If evolution is random, how can it predict anything? If it's random, a species that didn't have a wing could gain one wing and then gain another half a wing on the other side of the body, and then lose the wing that it gained on the right side of the body, let's say right, left, if it's random. So if the question is, if evolution is random, how can it predict anything? But someone was talking about the variety of dogs and the dogs that were on the ark. How do we get everything that we have from the dogs on the ark? Well, this would pertain not just to the dogs, but to everything that was on the ark. And that is this: God, being all-knowing, he would have known what two pairs of dogs or birds or fish, what fish went on there, but cats, whatever was on there, he would have known which two to bring on that have the greatest amount of variety, that was going to lead to the greatest amount of speciation. I believe he brought the animals to Noah. So the horse kind, he would have known which two to bring together to allow for the greatest amount of speciation. Whether the dogs were clean or unclean, God knows everything, so he would have known. Just like you know what you're going to get when you take a purebred shepherd and a purebred poodle, you know what you're going to get. God knew what he was going to get when he brought the animals to Noah. The ones that he bought, he would have bought them for the maximum amount of speciation, possibly. Those were the things I wanted to say. God knew what was going to come from the animals that he bought, the speciation that would be possible. And if evolution is random, how does it predict anything? That's my question.
Because evolution is not random.
The mutations are random, so they have selection for super guides evolution. Okay, can I make a point now, Donnie?
Mutations are random.
All right, so Andrew, you said the platypus.
If it's not random, what is it? Guided?
So they have something called natural selection, which is just a tautology, which is just saying that which lives. And that's supposed to guide,
Go ahead.
You never heard of natural selection redefined? Apologetics? Have you ever been to science class? I'm just playing now.
All right. So Andrew, you made the comment that the platypus is okay. It's okay if the platypus lays eggs, because
again, I have a lag. I've heard of that, but I would say I don't believe in natural selection, even though most people do, and that is because in order to have nature cannot select. Sorry,
there's no reason to assume that nature can't select. Like whenever you have a storm hit a town and some buildings are stronger than others, that's natural. That's like nature is selecting which buildings like maintain in the storm. So There's no reason to think that nature can't select.
Nature, no, the storm is not selecting anything. It just happens.
It's just
Yeah,
saying
they're
that
the
which
same
lives
thing with
live.
natural
It's a
selection, dude. It
tautology.
just happens.
It's a
So,
tautology.
so what you're saying
Reification
is it's
not nature
chance.
cannot
It's just by
select.
chance.
Okay,
It's
so
not
you
by
guys are
accident,
just
it's
having
chance.
this is just a language issue.
Yeah,
Like
it
this
just
is just
happens.
an
It's not
issue of
selection.
semantics.
That's
You
life.
just don't like that I've attributed
Redefine
selection
then.
to
What would
a
it be
non-mind.
then? What would it be? Do you think God is like controlling every little thing? Is that what it is, or what's your explanation for
There's
for
no
it?
selection going on. It's just that which lives.
Because it's more fit in its environment.
It's
No.
natural
It
selection is
doesn't
basically
have to be
life-
fit.
Well, I
Donnie,
just wanted to
talk,
hear
Donnie,
his
talk.
explanation for it, since he doesn't
Yeah,
believe in
that's
it.
life happens.
It only survives
That's what
because
it
it
Yeah,
is
but that's
fit.
not
It
really
doesn't-
an answer, though. I mean,
Yeah, that wasn't
it's
really
it's
an answer. But let
basically
Donnie talk.
differential reproduction. Who's reproducing the most? I would
Yeah.
argue it's a fine-tuning mechanism that keeps a species as strong as it can be. But I think,
Okay,
and
I'm
correct me if I'm
saying-
wrong, Andrew or Grayson, you would
So-
define macroevolution as change at or above the speciation level or the species level.
Correct.
Sure.
Okay. So I think the better question, though, is what is occurring on a genetic level? What is occurring in the genetic content of these organisms when new species come about? This goes back to the 2023 review of the Galapagos Island and the Darwin's finches.
Wait,
But
Donnie.
in 2017, when they observed that new species of finch form, genetically, if I'm not mistaken, it happened due to a shift in heterozygosity to homozygosity. So it was losing allelic variability. And as a result, it was labeled a new species. But that's what we would expect as creationists from the flood. You have heterozygous arc ancestors or arc archetypes. And from there, you have the sorting out of this allelic variability to create new variations or new species. But these aren't uphill changes. Go ahead.
There are multiple mechanisms that that explain speciation. Like polyploidy is one, where the chromosome number changes or even doubles, and then they're no longer able to crossbreed. But there's also other examples, just like ecological isolation.
With like fruit, like strawberries, and where like the whole genome basically duplicates.
Yeah, or like wheat, whatever. Like polyploidy has tons of examples. There's lots of flowers that have speciated because of such events. But there's also
Artificially or
isolation.
just in the wild on their own?
Yeah, in the wild, you can do this artificially, like we did with wheat. But yeah, it happens in the wild as well. But yeah, there is also like reproductive isolation. You just have like so many changes over time, just from two populations that are isolated from each other, that eventually the differences just become too great.
Right.
So let me
usually
address
it's
one
a
of
small- Go ahead.
Let me address one of the Andrew's points. He said like that the platypus laying eggs is okay because the platypus came from a reptile. Is that correct there, Andrew?
No, because mammals are not included in the reptile. Wait.
Yeah, like bubblegum. You could just
So,
say that like
let's back it up.
like
Let's back it up.
mammals evolved
The
from,
platypus
like,
is a
mammalia forms or like
No,
synapsids, and synapsids laid eggs.
So no.
Yes,
this
what
is
Grayson
crocodile.
said.
So you're saying why this doesn't count as a crocodile example, why the platypus doesn't count as a crocodile example, is because even despite the platypus laying eggs, it has a common ancestor with reptiles. It came from a reptile, you know, when its ancestor was a reptile, and so it's okay for the platypus to lay eggs. Is that correct?
Okay, bubblegum. I literally just clarified this point. I don't know why you keep insisting on.
No,
not
I'm asking
listening to the
Andrew. I'm asking
clarification.
Andrew.
He agreed with my clarification.
What is your clarification? And does Andrew agree with it?
Just change reptile to synapsid, and we're good to go.
What's synapsid? What do you mean by synapsid?
Hey, real quick, bubblegum, Donnie, I'm gonna hop off so you can let someone else get in here. It's been fun. Let you guys keep going. So I'll open up some safe for you.
If we're not using the category,
category,
later, Josh. If we're not using the category of reptile, what is this new category?
Okay, let me. No, I've got one person backstage that I'm not familiar with, and so in those cases, I just have to vet them due to things.
But
that
let me
have
get back
happened in the
to
past.
Andrew after that.
Yeah, of course. Okay, Dr. T-Rex, good to have
I
you.
know this guy, I think.
A spot just opened up. We're only allowed to have 10 on the panel, unfortunately. So, can you introduce yourself and let us know what your position is? I'm not hearing any audio from you.
Yeah, no one's here. Yeah, he's
Still
not
not
saying
hearing
anything,
any
Donna.
audio. You might have to deal with
He's not saying
your
anything. Yeah.
mic. Make sure you have a external
you
mic
might have-
plugged in.
Might have technical issues. I don't know.
You want to try again, Dr. T-Rex? You're on mute now. Still
Hello?
nothing. Oh,
Can you guys hear me? Can you
Yeah,
guys
we
Yes.
can hear you now.
yeah, we can hear you now.
Hello? Hello?
Yeah, we
Feel
can
free
hear
to
you
give yourself an introduction. Let us know what your position is.
Hold on. Is there any way I can hear you guys from the stream? Okay.
Can you
Uh,
hear
let
it
me,
from the
let me mute
StreamYard?
the stream on YouTube. Hold on.
Yes.
cool.
Yeah. Make sure the
I just
YouTube
wanted to
one's
say
muted.
my name is Dr. T-Rex, kind of a play on the name Dr. Dino. I guess my position is I'm a young Earth creationist, but I just wanted to kind of attack the foundation of the theory, which is that
it's not even a theory,
the
speculation, man.
evolutionists basically believe that all life came from a single-celled organism 3 billion years ago, and it's something that the evolutionists, whenever Dr. Dino does debate, Ken Hovind does debate these evolutionists, they kind of always shy away from it. He'll say, do you believe that we all evolved from a protozoa? And they'll say like, what? I don't know what you're talking about. And if the foundation of the theory is that all life originated from a single-celled organism 3 billion years ago, where is the proof of that? And they keep saying abiogenesis is not part of the theory, but if Darwin called his book the origin of species by means of natural selection. Well, all natural selection does is assume that life already exists. So, where's the evidence that life did evolve from a single-celled organism 3 billion years ago?
It's a weird question, but the fossil record.
Fossil record does not show that. Fossil
Uh,
record corroborates creationism.
That would be totally false, actually.
No, it doesn't.
No, it's actually right. It's actually precise.
That's just your opinion. No, it doesn't.
No, that's actually a fact.
Well, why don't you
Calling it a
substantiate
fact
it
doesn't
then?
make it a fact.
Yeah, why
It
don't you
is a fact. I'm saying it's
substantiate that?
reality.
Explain your point.
Well, you're just declaring that it is. That doesn't
All right,
mean
let me
anything.
just
I'm
finish up
actually
with
stating
Andrew
the
real
fact.
quick, and then we can get to that point. All right, so Andrew, so the reason you say the platypus doesn't count as a crocoduck example, which would debunk evolution, is because the platypus, despite laying eggs, it's okay that it lays eggs because it comes from a reptile ancestor. Correct?
Stop saying reptile.
What category you want to
It
use?
doesn't come from a reptile. Synapsids are not reptiles.
What are synapses?
They're amniotes, which lay eggs.
I'm sorry, I can't hear you guys on the StreamYard website
Amniotes.
for some reason. Is there any way to fix that? All I can do is hear myself.
I think it's an
Probably
amniote.
plug your
T-Rex, do you hear me? Check.
Wait,
There's
so
no
you said
audio
it
on the
came from a
actual
snail?
StreamYard.
Well, that's
No,
not good.
not a
come
snail.
back
bubble.
in.
I'll type it in the
T-Rex.
private chat so you know how to spell it.
Yeah, I typed it. I got a freaking snail.
Synapsids. You're not spelling it right.
I typed in amniotes.
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 Like an amniotic fluid that we all have.
Here, I'll type it in the private chat.
So that's a lizard. I'm getting a lizard.
No. Lizards are reptiles. Amniotes are pre-reptile.
Pre-reptiles. Okay. Pre-reptiles.
And also, just like amniotes are a larger umbrella category. Like deer amniotes, reptiles are amniotes, birds are amniotes.
I know, it's your fantasy. Let's just play by your fantasy. Okay.
We all have an amniotic egg sometime in development.
I mean, they
That's
do
what
believe in
defines
evolution
an
of fantasy, so I might as well just let them have.
So okay, so it's okay that they're despite the platypus being a mammal, because you have they come from amniotes, which lay eggs, and therefore
yes,
it's
because
okay.
the ancestral condition of amniotes is to lay an egg. That's what defines amniotes.
Now, if we had an ancestor in the lizard area that didn't lay eggs, would you consider that a crocoduck example?
Like an actual lizard that doesn't lay eggs?
Yes.
There are lizards that don't lay eggs, but no.
So you're saying you cannot use this? We cannot So evolution becomes basically unfalsifiable because
No, there are things that it just so happens that
look, you're not applying it
lizard.
consistently. You're not applying this line of argument consistently.
Well,
Because-
I gave some examples earlier.
Look, lizards don't come from mammals, correct? So you can't
Correct.
say
No, they're
lizards.
completely different lineages.
There's the point, Andrew. Lizards don't come from mammals. So why is a lizard giving birth? It's a crocoduck example.
It's
What
giving
you
birth in a
wanted.
different way than mammals. That's
Oh my-
Yeah,
the
it's
distinction.
like
we might
a
have to just move past this.
Andrew,
honestly.
The principle is that it's giving birth. Though.
it's a
You would
crocoduck
really have
example.
to get
It
into
fits
the
your
anatomy of
category.
it
It's supposed
to
to
see
lay
the
eggs.
It fits
like
your,
like
it
the,
fits
the
your category.
mechanism the mechanism by which lizards give birth is totally different than placental mammals
right.
or marsupials.
That's the
Yeah, but that
distinction.
doesn't prove common descent.
No,
They don't.
you
Doesn't
can't-
necessarily.
We're
prove
not
that they
trying to
share
prove
a common
common
ancestor.
descent. That's not
That's
the
what the
No,
whole
point.
theory
it
is based on.
eliminates
The whole
common
theory is based on
descent
common
right there.
descent.
Yes,
Exactly.
exactly.
We're
Exactly.
responding to Bubblegum's question, which was
You
not about
eliminated
common
common descent.
Bubblegum,
This
do you
eliminates-
just have a problem with its classification?
No, look. If
What
his
is
line
your
of
what is the point? Get to the point. Like these
Okay.
guys have been answering you, and you just brush them off. Like
Lay on
they're
the
not
plane,
willing to-
Bubblegum. What's your
yeah,
what's
we
your
need to move-
evolution
move
defeating
past
argument?
this.
Andrew wanted a crocoduck example. I gave him a crocoduck example. He's not willing to take it now.
And I clarified that with the crocoduck example, I'm looking for the exact same trait having evolved the exact same way in two different lineages.
We see that
The
with
lizard
the Fox
doesn't meet that
P2 gene.
criteria. The platypus doesn't meet
We
that
see
criteria.
that with a Fox P2 gene, right? That's a Fox P2 gene is a clear example of that.
In what organisms?
It's
Are you just
present
trying
in
to
the
say that
humans and it's present in the birds.
Are you
Some
saying that
birds.
convergent evolution is the
There-
same
you
as,
stop
like,
presupposing evolution. There's no such. You're presupposing evolution to justify to prove evolution.
Well, maybe if you had just let me finish my question, you would have understood what I was asking. I was asking you because we would consider these things that you're bringing up to be examples of like convergent evolution of like traits.
But when
But
I give an example of
Okay,
crocodile,
again, you
you're just
still
gonna
don't
say
allow me to
convergent
finish.
evolution.
Dang,
No,
Bubble-
this-
Bubble
Bubblegum, you're
finish
just
his
so
argument.
hype. You're just so
Bubblegum,
excited to
let
get
him
in there.
finish. Let him finish. Bubblegum. They'll dig themselves into a hole.
He hasn't really had a turn, so I understand.
Okay, I want to say, like, you're bringing up examples that we would consider to be convergent evolution. I get that's a very triggering term for you, but are you wanting to say that convergent evolution is the same thing as like mosaic fossils?
Mosaic. Look, when you're saying convergent evolution, this is just an attempt to explain away the crocoduck. I gave you when people are talking about convergent evolution, it's saying, well, how did this animal evolve the same traits as this animal when they're
It's
not part of the
the
same
trait.
lineage?
That's the point.
When
It's
they,
not the exact
it
same
is
trait.
the same. It is. It's literally
Then
the
show
same
how it
freaking
is.
gene.
It's the same because they're not laying eggs; they're giving birth, right? Is that what you
Right, but they're giving
But I'm
birth
also giving another
differently, so it's
example.
not
But the
same
principle
trait.
is that they're giving birth. A reptile usually
No,
lays eggs.
he
That's
he
what
already
it's saying.
moved past that example. He's on the Fox P2 gene now.
No, yeah. Andrew wanted what's more specific. I gave him something more specific.
And is that
So
gene
what-
found in
so
any
what reason are you
intermediate
complaining
groups
now, Andrew?
between birds and humans?
So they have the same gene. And
Right,
there's
but is
clearly
that
no
gene found
ancestor
in any
between.
intermediate other groups besides birds and humans?
Clearly, humans and birds don't have a similar lineage, right? A close lineage.
That's my question is specific. So that gene is found in birds and is found in humans, right?
Well, Andrew,
Is that correct?
That's an example of a crocoduck in your face.
Is that same gene also found in any other groups in between? Yes or no?
To my knowledge, it's not. It's an
Any-
example
Doesn't
of
have- doesn't
convergent
have to.
evolution.
Okay,
Okay.
that's what I wanted to clarify.
Are you gonna give up evolution now? You've been
What
proving
about
it.
No, it's
Andrew?
not an example of a mosaic quality.
Andrew, what about orphan genes? And I understand, we can get into de novo gene synthesis and gene duplication and so on and so
Yeah.
forth. But is this not what a creationist would expect, that we have these taxonomically restricted but yet essential genes? Okay, let's say in humans that aren't found in chimpanzees, that aren't found in gorillas. And they're called orphans because where's their parents? As in, there's no evidence for the precursor genes that led to these orphan genes. Like if I were to show you 3 different books, I could show you sentences in book 1 that are unique to book 1, as in they're not found in the other 2 books, and so on and so forth with the other 2 books. And so we do have unique functional genes that are only found in one creature but not found in another, and no evidence for their evolution.
Well, I would say that
really
doesn't
quick. I
strictly.
was
Go ahead.
incorrect. I want to specify I was incorrect. FOXP2 protein is also found in fish, reptiles like alligators, zebra finches, and mice, and like chimpanzees, and tons of other things.
Okay, thank you. That's what I wanted to clarify if it was found in any other groups. So what was I gonna say? So yeah, so what you said, Standing, isn't strictly true, I would say, because you have the actual orphan gene in one species, right? But in other species that we would consider closely related to it based on other lines of evidence, you find a gene that's homologous to it that doesn't actually code for like a functional protein, but codes for like an RNA that ultimately would fold up into that protein. So you do still have evidence of the nested hierarchy there. And yes, it probably a lot of these cases does go back to de novo gene origination, but you still have evidence for its evolution.
You're to me, that seems like evolutionary philosophy, and feel free to challenge me. But so you're assuming that in a closely related species, let's say chimpanzees. So we have these taxonomically restricted essential genes in humans. But you're saying, well, we find, because you use the word homology. So we find a similar gene or DNA element in chimpanzees, but it's a non-coding gene. And so that could be, or give us an idea of what the ancestral gene looked like before it mutated or altered in a way that became the orphan gene that we're looking at in the human genome. Is that more or less what you're saying?
Right, and it doesn't even have to be between like chimps and humans, for example. It can be between species that most creationists would consider a single kind. So, like pigs or something.
That non-coding RNA gene could be there for a functional reason, doing what it does. We know there's RNA products produced all the time and not protein products. You're assuming, or it seems like you're imposing on it, well, since we have orphan genes, now we got to find some homologous genes in closely related species and argue, okay, this is an example of what the ancestral gene would have looked like. But you haven't demonstrated that in the lab. We haven't observed that non-coding RNA gene mutate in a way where it's an essential gene that we would call an orphan gene in humans, for example. Isn't this a lot of historical reconstruction going on?
Well, like you do have experiments though where they take basically gibberish nucleotides and mutate it in such a way that not like by random mutations, and it forms a de novo gene with a functional protein. So that has been observed.
So you're arguing that in the lab, they've mutated a non-coding section of the genome and they've altered it in a way where it produces a functional protein?
Right. Yeah. You have mutations in that region, random mutations, and it produces it now. That de novo gene now produces a functional protein or a functional product of some kind.
Okay. What would be the best paper you could cite for that?
I could try finding it offhand.
Well, you don't have to do it. I don't want to put you on. Maybe just send it to me, and so
sure,
I could. Yeah. Is this with fruit flies?
I'd have to look at this. The specific paper, but I think Creation Myths might have brought up at some point in one of his videos. So I'll have to look and see what specific paper he was mentioning and if there are any others like that.
Yeah,
I can send it to you if you want.
I would definitely like to see that paper if the claim is that, hey, we've got a non-functional part of the genome, it's non-coding, or it's just producing an RNA product, and it's been mutated intentionally, I guess in the lab is what it sounds like. and the mutations or series of mutations altered it from a non-coding RNA gene to a functional protein coding gene, something brand new.
Yeah, I'm pretty sure that's been observed, but I could be wrong.
I believe I've seen this study too. I don't have it in front of me right now, but I believe like they just added like random inserts of just like completely random orders of nucleotides and onto like like a coding gene, and just to see what would happen, and then like a pretty decent percentage of those ended up being more efficient and more functional than the original, just by adding like random information basically.
I think there might have been a different paper that, yeah, I'll have to look and see if which specific one it was.
That could be a
I can't
different
cite
paper
it off.
though too.
But regardless of the evolutionist explanation for, I've heard de novo gene synthesis, like we're talking about non-coding regions of the genome. They can be hit with mutations and become a functional coding region or element, or, gene duplication, basically non-coding region duplicates, and then it's hit with a series of mutations, it becomes a functional gene, becomes an orphan gene. But the greater point is, the orphan genes that we see, the distribution or the patterns in orphan genes that we find across the biological world, they don't really have a consistent hierarchy. It's a little bit all over the place. Would you at least agree with that?
In some cases, yeah. If I may, like, ask a follow-up question, then, if many orphan genes are found at the species level, then doesn't that also negate what you would say would be created kinds, a common ancestry within a kind, basically? Like, it feels like you can't have it both ways.
That right there is a fantastic question. And I feel like we could do an entire orphan gene debate and discuss that. But yeah, that's the greater question of, okay, we see these taxonomically restricted and essential genes today in extant species. How can we trace those back to the precursor ancestors or the original created kinds? Because, and I'll show this visually, I think it's easier, because again, it's a really good question, is because we would all agree that there's diversification, there's variation, speciation. And so let's say from creation, right, you have humans that are created with certain sets of orphan genes, or take dogs, canids, they're created with certain sets of orphan genes. After creation, once they start moving out, or even after the flood, let's say 4,500 years ago, once they start moving out and you have speciation events, isolation, inbreeding, so on and so forth, you're getting the sorting out of the original orphan genes, right? Where maybe now you have lions with certain orphan genes that tigers don't have because of divergent speciation, so on and so forth, right? So yeah, those original orphan genes are now spread out in a way where they can be species specific. And so the question is, how can we take, let's say, species within the felid family, and take the orphan genes that are specific to lions, the orphan genes that are specific to cheetahs, leopards, and say which ones were all in the original archetype. Does that kind of make sense, Andrew, what I'm saying?
I think so. I have some issues with it, but I, like you said, I think that could be a whole other conversation, and we have been going back and forth.
Right, it would kind of be like this. So here on the phylogeny, you got humans, right? So they're created with all the different orphan genes. Then they move out, and let's just say after the flood, you get groups moving away, breakaway populations. You got Denisovans, Neanderthals, Erectus. Well, they're going to take subsets of the original genetic variability and DNA elements with them. And so that means Neanderthals could have their own orphan genes that, let's say, Floresiensis doesn't have, but their common ancestor over here would have had them. But
so you're saying kind of like alleles segregating out, like individual orphan genes would be segregating out under your model,
right? Because it isn't by definition that kind of how speciation or variation. I don't believe humans can speciate, but let's say, whatever the gorilla ancestor was or chimp ancestor, the breakaway populations are not going to have. There is going to be a sorting out process, correct? in speciation, where we have the inbreeding, especially if you're reducing shifts in heterozygosity to homozygosity, like we're seeing in these papers, specifically the finch species. By definition, that's a loss of allelic variability. And so many of the orphan genes can be lost. Let's say in one lineage, the orphan genes are lost, specific ones, but then in another lineage, they're retained. So yeah, it's species specific, but it doesn't negate created kinds. We have to figure out what orphan genes were present in the original created kinds.
Yeah, I see
Yeah, I
what you're
think it
saying. I
does.
feel like I still have issues with that explanation, but yeah.
Well, see, I would argue, and I know someone else was going to say something, and I think we're going to start winding it down because I said at the beginning we're going to keep this about 4 hours. It's been about 4.5 hours. So I'll say this, and then you guys go at it for a little bit, then we'll wind things down. It's been fun. We got many more of these this month, though. So I would argue it's much easier to break a gene. It's much easier to lose a gene than to build one up from scratch. And so orphan genes have been lost over time. Where, yeah, they are species specific, but were they species specific going right back to the creation event or even the flood, before they were lost or before they were segregated? I would argue not necessarily. So, yeah, I think the better explanation is orphan genes have been lost or broken down rather than built up through de novo gene synthesis or gene duplication, so on and so forth. Anyways, go ahead. What are your thoughts on that?
Yeah, I would just say in the conventional evolutionary model, you can have gene loss and de novo gene origination. So it kind of depends which one you're talking about specifically, but it probably is a combination of factors.
Let me just clarify real quick. See, I said, no, I don't believe in genes from scratch. My point was it's much easier to break a gene or to lose a gene than to build it from scratch. So where the evolutionists would say, well, a lot of these orphan genes are species specific is because they've been added. I would argue, no, a lot of them have been lost.
And I will freely admit that it is a very it is a field of research that is still ongoing, as most scientific fields are. So we of course don't have all the answers.
And for us too, creationists, because you asked an excellent question. Because the first question is, how do you explain orphan genes? We would say they're created, right? That's why we find them unique to various kinds. But then, you would argue de novo gene synthesis, gene duplication, so on and so forth. But then the next question, the bigger question, and it's a great question: why are they species specific? And I think that's where it comes down to the separate ancestry versus the universal ancestry model. In how can we explain the pattern of distribution of orphan genes?
Sure. Yeah.
Wait, first of all, let's not play around. There's not only two sides. There's like more sides. There,
the polytheist side,
the real creationists, as I like to call them.
You could probably fit on one hand the number of serious polytheists out there, right? Bubblegum.
I think I am the only polytheist.
Right, yeah.
I see one other guy, but that's about it. But I'm basically the CEO of polytheism.
Right, you're the founder of the Church of Polytheism.
We have
polytheism
species.
Nah, we're against the Church of Religion.
Yeah,
like
as
Norse
things
gods,
are winding down, I am gonna
like Greek gods and stuff like that? Or like
We're not
I was going to ask real quick.
goals.
I actually wanted to ask Grayson this, but he left. But we're going to have many more of these. Another, as we start to wind down, another major, and we've talked about this many times, Andrew, going back 2-3 years, but another major break in the hierarchy, and it's only getting worse as we get better genomic comparisons of the Y chromosome, is the Y chromosome. I mean, humans and chimpanzees, the Y chromosome in chimpanzees, for sake of time, I won't pull up the chart, but I usually do. The chimpanzee Y chromosome is, I'm just going to mute Robert, whatever he's doing there. It's only half the size. Heterochromatin's totally different. Gene content's totally different. And when you consider overall size differences, architecture, and gene content, the human Y and the gorilla Y are more similar to each other than either are to the chimpanzee Y. And so there's us sticking as close to home as possible, and yet we have an inconsistency in the hierarchy. Andrew, what are your thoughts?
Yeah, so I guess the thing I'll leave it with right now is that uh, when we say overall gene content is different, that could, I think, just as easily be due to the fact that the gene number could be different, for example. So, of course, in the evolutionary model, you have duplication events. So you have sections of the chromosome that can be duplicated many times. And I think, if I remember correctly, many of these ampliconic, or I forget the exact term for it, but these
Ampliconic
genes.
region.
Yes, thank you. In those kinds of genes in the Y chromosome specifically, a lot of them seem to be repeats, copy and paste of each other. So I think that is probably a big portion of it.
But doesn't this sound? It does sound to me like evolutionary philosophy, because I believe that the evolution community currently lacks an explanation. Currently, it's an ongoing research project, because when we look at it here, here's the chimpanzee, half the size. Here's your heterochromatin, right? The densely packed pieces of DNA that typically comprise repetitive sequences, as I think you pointed to, satellite DNA. And so here's the heterochromatin in humans. It's barely present. If I can see it correctly, I think it's a little bit here. The euchromatin, different. Again, the size difference, the architecture, everything is just so different. And then if we look at the gorilla is a lot more similar, but still pretty dissimilar to the human Y. But again, these two are more similar to each other than either are to the chimpanzee. But the evolutionists, and you can see it reflected here on this graph in this image, humans and chimpanzees go back about 6 million years to a common ancestor, right? Then we have the split right here. The chimpanzee line broke up into bonobos and chimpanzees. Anyways, it just seems kind of like a lot of guesswork. Well, maybe this duplicated, maybe this was lost, maybe this is copied, maybe this is pasted, or maybe the Ys are so different because humans and chimpanzees are just not related. That just doesn't seem to be a question on the evolutionist mind. The question is more so, why are they so different? But there's a lot of difference here that's going to, and I like to say it's the differences that make all the difference, right? But anyways, this single point here, Andrew, this would be an inconsistency in the hierarchy, would it not?
If it, like I said, we could go on a whole tangent here. Like,
Right.
if it did turn out that way, then yeah, it would be a big open question in the nested hierarchy. I think the major point is that you can consider like the Y chromosome individual observations, lines of evidence, but you also have to take into account the things that are already explained pretty well, or observations that haven't been explained yet, but like aren't necessarily contradictory. Like there are many different lines of evidence. And so I just feel from a scientific perspective that taking one and going with that and forgetting about the rest, or kind of leaving that out of the picture, is kind of misguided.
Yeah, you're saying look at the bigger picture. It's about the totality. It's about the weight of the evidence, right?
Yes.
And I would agree with that. Separate ancestry versus universal ancestry. I think there's a lot of agnostic lines of evidence. There might even be some evidence that the evolutionist position can explain a little easier. And then there's lines of evidence that the creationist position can explain better. And so I would argue that the creationist has more differentiating lines of evidence than the evolutionist. And so I think when the evidence is weighed, the separate ancestry model comes out on top. And so, yes, it's about the totality of evidence, the totality of information. I just find it interesting on the Y chromosome. Feel free to speak to this, Andrew, because the Y chromosome is uniparentally inherited DNA. It's only passed down paternally, right, on the father's side. There's little to no recombination. So it should be less messy than autosomal nuclear DNA, which experiences recombination. Every generation, you've got meiotic recombination, right? The chromosomes line up, exchange genetic content or information, reshuffle, we get new combinations of chromosomes. So it's a little messy, okay? But you don't get that in your uniparentally inherited DNA. And so you'd expect them to be a little bit more stable. But yet it turns out the Y chromosomes are actually the most different. So it seems to go against the normal expectation. And that's why I argue it is a differentiating line of evidence, because the question is, can the evolutionary community explain it? And so far, this is from 2020. They've put out a couple possible explanations, but they argue here that these, notice this, they need to be evaluated. They need to be studied. They need to be researched. So, I mean, until that's done, the evolutionist model lacks an explanation, at least for this specific point. Andrew, go ahead, my good man.
Yeah, I don't know. In to my understanding, at least, I feel like those studies have been done in the intervening years. I feel like at the end of the day, we're just gonna disagree on whether a particular explanation actually fits the data. And it's weird because I know the point's always made that it's a differing worldviews, for example, and I often think that it doesn't go back to that in many cases, but perhaps in this case it does.
Well, I'll say this as a final word, and then we'll shut it down right at the 4.5 hour mark. I think this has been a lot of fun.
Yeah.
From 2020 to 2024, feel free, if it exists. I don't think it exists. I try to stay on top of this. If there's been further research done to back up or confirm the hypotheses of sperm competition, faster rates of gene conversion, faster mutation rates, so on and so forth, send that to me. And what I'd be looking for is a sophisticated mathematical model that can explain all of this gene loss, the evolution of entire gene families, really, and the rearrangement of significant chromosome parts and genetic content, and that would at least be a start to addressing the Y chromosome challenge. And so if that exists, Andrew, feel free to send that, and let me throw it to you for a final word on that topic, and then I think we'll start to wrap things up.
So sure, yeah, for that paper and the orphan gene paper as well, is there any place you'd like me to send it to specifically?
Yeah, just the normal email, standingfortruthministries@gmail.com.
Okay, all right.
All right, well, this has been... Oh, go ahead.
Yeah, I was just gonna say, yeah, this has been a lot of fun. Thanks for letting me engage some of these points, and I did want to apologize earlier for kind of interrupting you at some points. I think we both, as well as Grayson, got really fired up tonight. It's been a lot of fun.
No, I think it was good. I don't think I once thought, hey, this is heated. No, this was great. This was a lot of fun. It's the debate dojo, and conversations involve what? Healthy interruptions, clarifying questions. It's not just monologue. It's about having a free flowing and organic discussion. I think we had a lot of fun discussing transitional fossils. Andrew, what I'd really like to discuss next time is cytochrome C.
We didn't get to that.
Right. DNA level hierarchies is what I want to discuss next.
Yeah, that'll definitely be something for next time then.
It's always good when you join and Grayson joins, and it's a lot of fun when we have informed evolutionists on the panel for us to spar with.
Thanks for having us on.
Yeah, my pleasure. Anybody else got any final words, final thoughts as we wrap it up here at the 4.5 hour mark?
Yes, man. Yeah, I want to say my bad for my bad for the disruption. I was trying to make life from an amoeba. I was actually like in my seat.
You've been doing an experiment this whole time.
Yeah, I'm trying to prove that. Yeah, I'm trying to like actually experiment with the evolutionists are saying. Right, Andrew? I'm just playing. But yeah, I just wanted to say this was great. Hopefully we're definitely gonna have more of these, and hopefully the evolutionists can finally see like how flawed their concept is, and and accept the truth, the true position, which is creationism. But yeah, this is great. God bless you all.
You underestimate the power and wonder of amoebas all by themselves, my friend.
Yeah, after that, you're going to jump and I'm going to cut your legs off. That reminds me of the
Amoeba
Obi-Wan
Wars.
Anakin scene. After you said that, you underestimate the wrath of my powers, and then you're just going to jump. Were you going to say, Donnie? I'm sorry.
No, this is great. Anybody else have any apologies to Professing Preterist and Dan? I don't think you guys got a chance to
It's okay.
talk. It gets a little difficult once we get to the 2-hour mark and it's just a free-for-all. It gets kind of hard to coordinate people's responses. But gentlemen, feel free to have some final words if you'd like to.
Yeah, Professing hasn't said anything. But does he even know creationism? I feel like I just see him in the theology debates.
It's all in the past for Professing Preterists. It's all in the past.
Isn't he a conditionalist or something?
He is one of our favorite conditionalists. We'll have to do a soteriology open mic too. Dan, I saw you unmute real quick. Go ahead.
Yeah, I was just gonna say if evolution, but this is for Andrew. If evolution was such a science, why would it would be so argued like this? Like, why would people so go against science? You know, like what's so like it's more of a philosophical debate, don't you think, than a scientific one? Because if it was as obvious as gravity,
yeah,
nobody would be arguing.
That is a very good question, and I often wonder the same thing about anti-vaxxers, flat Earth, whatever. So that is a very good point.
Evolution is just like flat Earth. Honestly, you guys are in the same boat.
Ooh, those are fighting words that could result in another 5-hour open mic.
Real quick, let me say one thing real quick. You mentioned DNA and the Y chromosome and humans getting smaller through every generation slowly. Just wanted to let everybody know the Bible says that the universe is running down and that the universe is subject to destruction and that it is a curse because of sin. So every time we see genes getting destroyed, we notice that it's harder to build genes than it is to destroy them. That is evidence that creationism is true and that there is a God. That's all I'll say, and I'll let you guys go.
Dr. T-Rex, are you related to Kent? I wanted to say that.
No.
Okay, yeah.
I'm not a doctor either.
Oh, yeah.
Dr. Dino and Dr.
You're just a
T-Rex.
You're just a Dr. Dino fanatic, I guess.
Well, they both go back to Adam and Eve, so in a way they're related. Okay, so my quick final words is we have many more open mics. Major thing we're going to be focusing on this year is just a lot of open mics. We did a lot of open mics last year, but we're going to do even more, put it that way. And so this one's coming up. I'm really excited. Yes, we've solved the heat problem. Evolutionists, of course, disagree, but hey, that's why we have an open mic. So this is coming up. I think it's the 11th. David M. Winsberg, he's published 2 abstracts at the ICC, which is the International Conference on Creationism. And so he's going to be giving a 2-hour lecture. And then we're going to do probably about a 3-hour open mic. So about a 5-hour show. And all the skeptics. Andrew, you're invited. Grayson, Erica, Dan, everybody's invited.
Wait, is Crocodile going to be there? Because I think he's the guy. I think I've heard him propose that against Winsberg.
Yeah, you know what? I'll probably email him and ask him to join too, because no, it's not David McQueen, David Winsberg.
Oh,
yeah,
David McQueen. Oh, this is a new guy.
Yeah, so David Winsberg, he's put out some detailed abstracts. He'll be giving a lecture. He's got numbers, physics, science. It's going to be interesting. And the entire skeptic community, put it that way, are invited to engage in some open mic debate. So, Andrew, I'm sure we'll be seeing you there, especially for the
I'll definitely try and join. I don't know how long I'll last, but we'll see.
He probably,
you know what? You last a good amount of time today, about 3.5 hours. So,
that's true.
All right, guys. Good job to all of you. It's been fun. Time's flown by. To the audience, thank you so much for tuning in. Appreciate the super chats, the questions. Apologies for the super chats and questions I didn't get to. It's been fun. It's been a good open mic. It was an excellent debate between another skeptical guy and Dr. Dino. And all right, we'll see you guys in another couple days. Stand for Truth is out.
God bless you all. See you.
Happy New Year.